Welcome to TSAT. Now I am going to discuss a topic in geography known as groundwater. So here, in the case of the groundwater is considered, groundwater exists inside the layers of the earth, especially the rocks, which is been described as water table, and this is also known as an aquifer. So here in this case, in the case of this groundwater, the source of groundwater is precipitation, means rainwater. So when it rains, what happens is, because of gravity, the water flows. The flow of water happens in two ways. One is surface runoff, the second is percolation of water vertically downwards. So depending upon the nature of the rock in terms of porosity and pervious nature, the water percolates down. In the absence of porosity, the water doesn't percolate down. The water is being subjected to surface runoff. Water table to form, or for an aquifer to form, there are certain essential prerequisites. What are the essential prerequisites for the formation of a water table or an aquifer? The essential prerequisites for the formation of an aquifer is, for example, the rock must be porous, means the rock must have many number of pores or fractures or cracks. So here in this context, apart from this nature, the rock must be pervious. So the difference between porous and pervious is, the pores and fractures must be interconnected, allowing the water to flow from pore to pore. Then only a rock can act as an aquifer. So our aquifer is otherwise also known as a water table. So these are the basic conditions required for the formation of an aquifer. Apart from this, the bottom rock must be impervious, means it must not have any pores, because if the bottom fundamental bedrock is porous, the water escapes down and the availability of water in the rock doesn't happen. So other important fundamental factor apart from porous and pervious nature, the bottom bedrock must be impervious. These are the conditions essential for the formation of a water table. So after understanding this, see the projected image to you are able to observe certain pore spaces. So these kind of pores, fractures and interconnection of these pores and fractures is essential. Then only there is a formation of the possibility of formation of water table can exist. Otherwise, when a rock is impervious, there is no possibility for formation of a water table. That is the reason why when we have a bore as a borewell to extract water at different places, sometimes we may not be able to get water because when the rock is not porous and pervious. So to make you understand what I have discussed with you in terms of understanding the water table. So here you have got different layers. In these different layers, you have got different colors here being given to you. The more or less the brown color rock layers, these are different layers of rocks being given here. In these different layers of rocks, these are impervious rocks. These brown layer rocks are impervious rocks, means they will not allow the water to pass through. So for example, the aquifer or a water table is being defined or described here is unconfined aquifer at the top. At the bottom, confined aquifer. Both are water tables. The difference here is, in the case of a confined aquifer, at the lower level and at the upper level, in both ways, there is an impervious rock. So when when an aquifer is being bounded both beneath and at the top by an impervious rock, we call it as an confined aquifer. In an unconfined aquifer, only the bottom layer bedrock or the basic rock at the bottom is impervious, whereas in the unconfined aquifer, the top layer doesn't have an impervious rock. So here in this context, to understand what is an artesian well, so we have got two bore wells here. we have got 2 bore wells here. So here in the case of an unconfined aquifer, what happens is for the extraction of water, you need to use certain energy. The electrical motor need to be used to pump water upwards. But in the case of an artesian well, what happens is because the source of water of recharge will be elsewhere, which is much more higher in terms of altitude. Because of the gravitational pressure head, water pressure head, what happens is water emerges out through the bore being made, which has been described as an artesian well without requirement of any kind of electrical motor or energy required. So this phenomena where with just making a bore when the water is being ejecting out without the requirement of energy is known as artesian well. So this is how you must be able to differentiate between an ordinary bore well and an artesian well. In this case, the classic example here having some of the largest artesian wells is in the case of the Murray-Darling Basin in Australia. We have got a very large centripetal basin formed by these kind of river systems, where because of this artesian nature, we have got abundant water availability, which is responsible for cattle ranching in these regions. So in this case of projection being given to you, as far as the water table depth is considered, is not constant always, but there is a permanent water table. So in this context, what happens is with the change in the seasons, for example, in our region, in the case of rainy season, because of more amount of precipitation or rainfall, what happens is the level of the water table rises above. And when we change of seasons, what happens is when it comes to winter or summer, gradually what happens is because the source is not there. For example, as it precipitates frequently in rainy season, it doesn't happen in winter and summer. Because of this reason, the recharging gradually decreases and the depth of the water table, what happens is increasing. There is a layer where to a maximum extent where the water table level can reach in rainy season, which will be reducing during summer season. So this reduces to this a permanent depth at which a water is retaining in a region is been described as a permanent water table. So the difference between the permanent water table and to the maximum level where a water can rise during rainy season, this difference in the depth is being described as intermittent zone. This zone is being described as intermittent saturation. Zone of intermittent saturation is the difference between the temporary water table level and the permanent water table level. So this can be asked as a question, what is meant by intermittent water table or intermittent zone, they may ask you. So this is a recharge place when it precipitates because of the percolation. This is how the water tables are being recharged from a catchment region. So for example, this region which is responsible for collecting the precipitated water to form a river system is known as a catchment region. This is a classic diagram of an artesian well because of the recharge area on the higher elevated region in this syncline or a depression. When the land is in this form, which is in a centripetal or in terms of a depression, what happens is the extent when it is, this extent when it is in hundreds or thousands of kilometers where the slope gradient cannot be observed by us, because of the overhead pressure, when we have a bore, automatically the water ejects out because of the overhead pressure of the recharging zone, results in the formation of artesian well. To differentiate between a geyser and a hot spring. So what is the reason for differentiating a geyser and a hot spring? So in the picture being projected to you, you can observe the variation of the diagrams here. For example, this is an example of a geyser and this is an example of a hot spring. So the difference between hot spring and a geyser is, in the case of a geyser, the water exploding out happens in an interval which is same always. So the time duration between two expulsion or explosions of water happens between an exact time duration. That is the reason why it is known as a geyser. But in a hot spring, irrespective of the time interval, there will be a continuous flow of hot water, which is being described as a hot spring irrespective of the time interval. Whereas in the case of a geyser, the expulsion of water will have an equal time intervals. The reason behind it is the chamber present here beneath the Earth's layer is having a certain volume. So, the amount of time consumed by the water vapor or the condensed water in the chamber, what happens is with the increasing in the altitude, the temperature decreases. So, the evaporating water, because of the magma available beneath, the water vapor evaporated in the lower chambers come and accumulate in this chamber. And when the chamber is being filled, the time consumed for the condensation and filling of the chamber will be always the same, because the volume is same. So, when the chamber is being filled, there will be a pressure building up beneath to push this water upwards. So, the pressure being built up will be equivalent to the weight of this water, and to an extent when it reaches the pressure being built up is equivalent or more than the weight of this water, which leads to expulsion of the water. So, that is the reason why otherwise a geyser is also a hot spring. Next, after discussing the groundwater, another area known as karst topography, which is otherwise also known as underground drainage system. So, this underground drainage system is observed in a kind of a rocky topography region, which is made up of calcium and dolomite, limestone and dolomite regions. We have got this kind of topography known as karst topography. In this karst topography, which is also been described as underground drainage, is because of a solutional activity. It implies that whenever it precipitates, means when it rains, what happens is this rock has got the nature of dissolving into the water. So, because of this reason, what happens is different kinds of features are formed on the surface of the earth and inside the rocky terrain region. So, this kind of topography is being described as karst topography. So, what are the different kinds of features being formed because of karst topography? The different kinds of features which are being formed in karst topography are, for example, the sinkhole. So, sinkhole is an example of here doline and sinkhole are being given as synonymous, slash has been given here. So, when many sinkhole is being formed a funnel shaped depression. Sinkhole is a funnel shaped depression formed because of the solutional activity, means because this is being formed by limestone or dolomite, which dissolves in water, precipitated water, leading to the formation of a funnel shaped depression, which has been described as a sinkhole. So, this sinkhole extends into a swallow hole. So, this is into the sinkhole you will be able to observe a blue line is a stream entering into the sinkhole. This stream entering into the sinkhole enters into this region known as swallow hole. This is known as a swallow hole because it swallows the stream and the stream disappears. That is the reason why the sinkhole leads into a swallow hole. When sinkholes, because of the solutional activity, the diameter of the sinkhole gradually increases. In this process, many sinkholes combine together to form a larger structure known as a doline. So, in this process, what happens is the underground passage of percolated water forms streams beneath which are not visible from the surface. So, because this rock itself is made up of limestone and dolomite, because it has got a solutional nature, means dissolving in the water. So, as the structure is being formed in the case of the surface region known as the sinkhole, a different structures are formed in the interior of this rock because of the solutional activity known as chambers and caves. So, it leads to the formation of caves inside. These are known as caves. For example, these caves are being formed because of the solutional activity of these limestone and dolomite. So, here in this case what happens is the percolating water you might be observing here dripping down, passing through because of the porous nature of the rock, drips in the caves from the surface of the caves. So, in this process, because of the solutional activity, because it contains certain calcium salts, when the water is being dripping from the surface or the roof of the cave, drips down drop by drop. In this process what happens is the drop, when it is hanging on the roof, when it evaporates hanging for a long duration, leaves the minerals on the roof. In this process, when this continuous process of accumulation of minerals, because of the evaporation of the hanging drop on the roof of the cave, leading to a slowly increasing in the accumulation of these salts, lead to an extension of a spike-like structures made up of minerals. This is which has been attached to the roof of the cave is known as stalactite. So, here the same way the drop which has been dripped down, which falls on the floor of the cave, which also evaporates, and another structure from beneath will be emerging upwards, which is known as a stalagmite. So, in this process, in this continuous process of dripping of water droplets because of the percolation of the precipitated water over some thousands and millions of years, what happens is the extension of stalactite and stalagmite fuses to form a structure known as pillar. So, chambers, caves, sinkholes, swallow holes, dolines are some of the structures which are being formed in the case of this kind of topographical structure known as karst topography. So, this is how you have got different features. You have got caves being formed interior, streams flowing, the river which disappears, sinkholes. So, the stream disappears into the sinkhole and swallow hole. This is known as a blind valley because, so in the examination they may ask you what is a blind valley or a sinkhole or a swallow hole or a stalagmite or a stalactite or a pillar or a column or a chamber or a cave. These are all different features which are being formed in the case of karst topography or underground drainage mechanism in limestone and dolomite regions. So, here for example, in the case of blind valley, so valley is being formed by the because of the weathering and erosion of rocky terrain because of the flowing water. So, in this context, here in the case of the blind valley which has been projected to you, a valley suddenly stops abruptly. So, when there is a sudden stopping of a valley is known as a blind valley in this karst topography because the flowing river suddenly disappears into the sinkhole and swallow hole and it forms an underground river. So, because the eroding and weathering nature of the flowing water continues beneath underground and it stops on the surface, and where there is an abrupt stop of the flowing river leads to the formation of a blind valley. Blind valley is a nature of a landform feature of karst topography. Sinkholes, caves, so these are sinkholes. When the solutional activity extends, what happens? Both the sinkholes merge to form a larger structure. So, this is because of the solutional activity. So, 𝗿𝗁𝗔𝗧, for example, when these sinkholes, this structure is known as a 𝗿𝗁𝗔𝗧. When the roof of the cave collapses because of the merging of the sinkholes and dolines, because of increasing in the solutional activity, this kind of feature is being known as a 𝗿𝗁𝗔𝗧. These are all the features of karst topography. This is how the solutional activity happens, leading to the disappearance of the flowing streams in a limestone dominated topography. The caves, we have got certain examples of these caves in India, in Meghalaya, Arku Valley, the Arku caves, and in the case of Kurnool district, you have got the Belan caves. These are classic examples of caves we have got in India. In Mexico, we have got these caves because of karst topography. This is how naturally this topography looks. This is a sinkhole where the water is disappearing into the sinkhole. So, because when we have got human habitations in this kind of topography, without studying the geology of a region, what happens is we will be having our habitations, the colonies, or roads, or etc. We don't know that the ground beneath is being subjected to solution and large chambers are formed beneath. All of a sudden, when the roof collapses, it leads to a disaster. So, when a human habitation or any kind of constructions are being allowed in a region, it must be approved by a civil engineer. Otherwise, it leads to these kind of disasters, because whether the topography or terrain, whether it is feasible for construction or not, need to be confined by geologists and civil engineers. So, this is an opening into a cave where the sun rays are able to pass through the hole when the sinkhole has been extended to form a blind valley or a 𝗿𝗁𝗺, etc. When the light enters into the cave, this is the view inside the cave. These are uvulas or sinkholes combining to form a larger open valley. So, it leads to the formation of different structures known as karst cones. So, uvula is originally a local topography used in certain countries like Slovenia, Croatia, etc. This is the vocabulary being used in these countries. So, a larger size than that of a sinkhole, So, all these activities which I have mentioned are because of weathering and erosional activity. So, the agents of weathering and erosion is one and the same. So, weathering, as I have specified, that a larger rock particles becoming smaller. Erosion is these smaller particles are being carried away from one region to another region. The agents of weathering and erosion are one and the same. So, what are these agents of weathering and erosion? The agents of weathering and erosion are the moving water from a higher elevated region to the lower because of the slope gradient, the moving ice, and the wind. These are the three agents of weathering and erosion. Even apart from these three factors, a phenomena known as mass wasting. Mass wasting means because of gravitational force, what happens is a larger rocky particles or soil because of the slope gradient being subjected to gravity falls down from a higher elevated region known as mass wasting. So, because of these phenomena, weathering and erosion is being subjected. So, this weathering and erosion has been described or been classified into physical weathering and chemical weathering. So, physical weathering is also known as mechanical weathering. This physical weathering involves the breaking down of rocks and soil through direct contact with atmosphere conditions such as heat, water, ice, and pressure. So, this physical weathering is caused by these factors. One is heat, water, ice, and pressure. Here, in the case of the heat, what happens is with the change in the temperature in the season or change in the diurnal temperature, in a day, the temperature goes to a minimum and maximum. According to seasons in a year, the temperature goes to, for example, in our region, the temperature goes to around 9 degrees or 10 degrees in winter. And in summer, it may go to 45, 46, 47 degrees. So, with this range of temperature, what happens is the basic nature of matter expands with increasing in the temperature and contracts because of decreasing in the temperature. Because of these factors, what happens is because of uneven expansion of contraction and expansion, because the outer layer of the rock is being exposed to heat, whereas the internal layer of the rocks are not being exposed to heat. Because of this reason, there will be an uneven expansion and contraction. Because of this uneven and expansion of contraction of these rocks lead to fracturing. So, because of this reason, the outermost layer which is being expanded and the inner layer which has not been expanded leads to the removal of the outermost layers. This phenomena of removal of the outermost layer because of the variation in the temperature is known as exfoliation, leading to the acquisition of rocks into a round shaped structures. In Telangana, in most of the regions, for example, when you see the outskirts, you have got rocks acquiring the round shape, as if you feel that somebody has kept somewhere else on the top of these hill regions. This is because of exfoliation. And we have got a mountain in Warangal, where you have got a smooth surface of this rock because of the phenomena of exfoliation. So this is because of heat. Water and ice, because there is a phenomenon known as anomalous expansion of water, where which is known as frost wedging. For example, water has a unusual behavior between 4 degrees to 0 degrees centigrade. For example, when the water temperature is decreasing from 4 degrees to 0 degrees, in general 4 degrees to 1 degrees, any matter, because of the decrease in the temperature, the volume must decrease, because with the decrease in the temperature, the matter contracts. With the increase in the temperature, the matter expands. But in the case of anomalous expansion of water between 0 to 4, with the increasing in the temperature from 0 to 4, water contracts, and water expands with the decrease in the temperature from 4 to 0. So in this process, what happens is when in the cold regions, especially when the water enters into the fracture zones, when the temperature is gradually decreasing, the density of water is maximum at 4 degrees. So because of this reason, the volume occupied by water will be minimum at 4 degrees, and water seeps into the cracks. And from 4 to 0, when the temperature is decreasing, the water starts expanding. This leads to the expansion of the fractures and cracks, and it leads to the breaking of the rocks because of the anomalous expansion of water, which is known as frost wedging. They may ask you what is meant by frost wedging. So because of anomalous expansion of water. So this is also a mechanical weathering. This is known as mechanical weathering because there is no chemical change. And pressure. So pressure, because of water and different kinds of pressure, rocks break because of wave pressure at the coastal regions. Hydraulic pressure of the waves lead to fracturing. So topmost terrain is being subjecting to erosion. Erosion by the moving river. So because the moving river from the higher elevated to the lower region has got kinetic energy, so which leads to weathering and erosion. And weathering and erosion by waves of the ocean striking the coastal rocky terrains, leading to weathering and erosion. And weathering and erosion because of wind. For example, when the wind is blowing, wind can carry away the sand particles from place to place, or the moving ice in the valley glaciers. When the glaciers are moving from the higher elevated regions because of gravity to the lower valleys, the frictional force existing between the rocks beneath the glacier, the rocks are being picked up, plucked by the moving glaciers because of their sheer weight and pressure. So glacials lead to erosion, moving water leads to erosion, the waves lead to erosion, the wind leads to erosion, and finally the mass wasting, landslides because of gravitational force lead to weathering and erosion. So all these leads to weathering and erosion, which is known as physical weathering. So by waves, frost wedging because of ice, and temperature, which is being described as exfoliation. Friends, these are the different types of physical weathering which may be asked in the examination. So we shall continue with the next topic in the next session.